This video is going to cover R.2 from the review concepts for Algebra 2. So this is order and absolute value. It starts out with basic information like the coordinate of a point and the coordinate system. So you can see this is a number line. Hopefully you remember what a number line looks like. On that number line are all the different values in order from smallest to largest. So the furthest left you move, the smaller the negative. So like a -5 is smaller than a -2. And then moving to the right, the bigger the number. This is comparison or inequalities. So something like A is less than B, or the symbol would look like this, and A is greater than B, the symbol would look like this. The larger part is always open towards the larger number. So example 1 is just like writing them in order from least to greatest. So for something like a root and a fraction, you would want to convert into either a decimal form or into a mixed number for the fractions, and then obviously decimal estimate of the decimal for the square roots. So 11/7 is like negative 11/7 would be like -1.6. Pi is like 3.14. Square root of 20 is in between two perfect squares, square root 16 and square root 25. So if this is 4 and this is 5, I would know this is pretty much halfway between them or pretty close to it, which is something like 4.5, and then -4.2. So then when you rearrange them, the larger the number that has the negative in front, the smaller it is. So -4.2, -11/7, pi, and square root 20. So we get into the symbols. Obviously, the less than and greater than are ones we covered already. And then this is less than or equal to, greater than or equal to. The same symbols with the slash through is it's not less than and it's not greater than. The words in between mean that it's literally in between the two. So for B being in between A and C, then B would be greater than one and less than the other. So we just want to get to know inequality statements. Absolute value is the positive version of that number. So whether the number starts out positive or negative, it will always come out of absolute value as a positive. By definition, the absolute value is the distance between that number and 0. So you can see if the number's 9, that the distance between 0 and 9 is 9. And if the number is -9, the difference between 0 and -9 is also 9. And it says down here, absolute value is always non-negative. So unless there's a negative in front of the absolute value symbol, it will always be positive. So if I have an expression, let's start with these down here, that's negative inside, it's going to come out as positive. This would be a +8, but then there's a negative on the front, so it's the only time you're going to see the negatives. This is a +8, a +2 on the inside, but then the negative changes it so that it's -2. And if we, if it says, give x being pi, then 2 times pi, absolute value of 2 times pi is just 2 pi. So there's just a couple more examples in here. Do the work inside the absolute value first, and then take the absolute value of it. And then here's just some examples and a review of all those properties of absolute value. So all absolute value would be greater than or equal to 0. Absolute value of a negative is just the number and the inside being positive. Absolute value of A times the absolute value of B is the same thing as saying the absolute value of A times B. Absolute value of A over absolute value of B is the same as saying the absolute value of A over B. And a less than A plus B is always going to be less than or equal to the absolute value of A plus the absolute value of B. So here are some examples which you'll get to work through in your packet. See if there's anything else we need to cover on the bottom. You're just evaluating expressions. So in these, you are taking these values and plugging them into the expression, working what's on the inside, and then taking that last absolute value step to make it positive. Distance between 2 points on a number line, you can use absolute value. So You can either say that subtract the two and always take the absolute value of them, or you do the bigger minus the smaller number. So distance between -5 and 8 can be -5 minus 8 in absolute value, which would be the absolute value of -13, which is 13. And the order won't matter here, because if I did 8 minus a -5, I'd still turn into 8 plus 5, which would be 13. Absolute value of 13 is still 13. So the order won't matter if you keep it inside the absolute value bars. All right, so for these exercises, and I'll post, I'm actually going to highlight it and do just this single page on Canvas, but just so that you can get started on it, you're going to do 1, 5, 11, 17, 20, 24, 28. 30,